Alright, today we are going to discuss and build the RCX H250CF-3K FPV quadcopter in kit form from myrcmart.com. This is a budget priced quadcopter kit that comes with obviously low end components and is definitely not without its faults. The first thing that you need to know if you bought the kit as they lay it out with the default motors is you will need to get some additional equipment in order to mount those motors. You will need to get 8 M2 6mm bolts for mounting. The hardware that it comes with only come with 2 of these per motor, and you're going to need 4. The frame is really designed more for a larger size motor that uses a M3 size bolt, and we'll get into this a little more later. You can get these usually from your local hobby shop for a couple of dollars per pack. $1.99 for 4 is what I paid, and obviously you need 2 packs. The other thing that they don't really even mention on their site is in order to mount your flight controller and your power distribution board, you really need to have a set of nylon standoffs. I have some from another model. They are relatively common in quadcopters, not so common elsewhere. They're M3 size, 6 or 8mm standoff is probably what you really want. These are about 4mm. I have these from another model that I crashed, and until I get replacement parts, they are spares, but I'm going to not use them because I think that most people probably did not realize that they needed them when they ordered this kit. So if you have these, they'll make your build a little easier, they'll make it a little better in my opinion. You should probably go ahead and order them if that matters to you. We are going to instead use some industrial strength Velcro for putting it together that you can pick up from Home Depot for a couple of dollars. So first off, we'll talk about what all you get with the kit. You have one bag that has all of the frame components and the included mounting hardware. This actually comes in that bag. You have 4 of these 1806 motors with some mounting hardware that comes with them. You have your electronic speed controllers and a pretty large number of props. These are pretty cheap props, so it's definitely a nice thing that they gave you a bunch of extras. Let's go ahead and look at these pieces. The frame itself has 2 identical plates that make up the base. One plate that goes above that. When it's assembled, essentially, the motor arms will be sandwiched between these 2 plates, and these aluminum risers will hold this piece roughly here. So the first thing that I like to do is go ahead and get the motor end built out. So we'll take our 4 prop arms, put the rest of this away for the moment. There's our prop arms. we're going to be mounting the speed controllers right in front of the motor on these prop arms. Let me show you the difficulty with mounting these motors. As I said, there's a number of screws in here. There are 4, or actually there are 6 M2 size screws. However, 4 of them are only 4 millimeters. You can see the difference between the two here. The 4 millimeter is not long enough to use to mount the motor. The 6 millimeter is, however, you need 4 of them. The other difficulty is if you look carefully at the prop arm here, you see you have slots running that way that are smaller, slots that are crossed that are bigger. The width of that slot versus the head of the 6 millimeter bolts, in my opinion, is too close. I think based on this being relatively inexpensive materials, if you try to tighten this down, you see it fits loosely in there. If you try to tighten it down, it's going to dig into the material and either pull through it or work itself loose very easily. So what we're going to do instead, you can see the mounting holes on the bottom of the motor here. We're going to rotate it 45 degrees so that it allows us to use the smaller slots. That's going to have your motor mounted essentially like this, with your wires coming out the side a little bit. Once we get it put together and bolted down, we can put a little bit of bend on that to get it mostly straight and not hanging off the edge. But it's definitely not, in my opinion, a good idea to mount this without doing that rotation. We're also going to remove the motor leads from the speed controllers and trim down the leads that come with the motor itself, so that we have the motor and the speed controller mounted close together without having a bunch of extra wire hanging off. So first thing I'm going to do is mount up the motors to the prop arms. This requires a 1.5 millimeter hex, which you can get one of these. I got a set of these from Harbor Freight for a couple of dollars, but I've used it quite a bit. It's a pretty good kit. So to get started, the bolt on the Allen, we push through, then we line up the first mounting hole and give it a few twists. We're not going to tighten this all the way yet because we need to be able to move it still. So we got the first one, we get the next one lined up visually, and we can get it started. And since we only have 2 that work with it, we need to get 2 out of our extras. And so, same deal. Now just make sure it looks pretty centered before we tighten anything down. The tolerances on this are so there is a little bit of wiggle room there. It looks pretty good here, so we'll just give it a little torque, not much. Remember, all these parts are going to be made of relatively cheap materials, so you don't want to treat them the way you would industrial equipment. You don't put much torque on there at all. And you see how the motor looks on the arm. We'll be able to bend it roughly that far to keep it within the confines of this arm when we actually go to mount it up. So I'm going to go ahead and do the other 3 motors off camera, and then I'll be back. Okay, I think I had a little technical difficulty with my camera, and it did not record the last segment, so I'm going to back up a little bit here. I'm actually a little farther than where we would have been. So let's really quickly review. I've completed mounting all 4 of the motors to the arms. They're mounted identically, so at this point they're fully interchangeable with each other. And we are ready to move on to the speed controllers. At this point, I went ahead and plugged in my soldering iron. It takes a couple minutes to heat up. Mine's already hot because this is the second time I'm doing this part. So let's talk real quick about the speed controllers. There's a new one out here, so you can see what we're doing. These are pretty typical 12 amp Simon K firmware speed controllers. The only thing that is at all really interesting about them is that they have a battery eliminator circuit that puts out a claimed maximum of 2 amps, where most of these would only be 1 amp. What that means is when you have the power lines connected to your RC battery pack or the power source, the red wire on this 3-pin connector, from red positive to brown negative, you have a 5-volt power source with a maximum capacity of 2 amps. The battery limiter circuit is usually used to power things like your flight controller. These can also be used for other non-RC purposes. They make really good power supplies for things like a Raspberry Pi. Later on you'll see I'm going to use one to power an Arduino for testing the motor and ESC combos once they're together. But this is pretty typical of what any of these would look like. The process that we go through is going to be the same. You notice that the wires on the motors are quite long. The wires on the speed controller are much shorter. It's a lot easier to connect the motor wires to the speed controller than to try to connect the speed controller wires to the motor. When this is all said and done, the speed controller will be mounted roughly here. So as you can see, there is a lot of extra wire here. So the next thing that we're going to be doing is removing these wires from the speed controller, and then we'll see about getting the wires for the motor soldered into the speed controller. The first thing that we'll need to do is remove some of this insulation from the top of the speed controller. You can tell the top because it has a flat heat sink on it. It's pretty obviously flat. The other side, you can feel there's some components there. So we need to be removing the material from the flat side. To do that, I'm going to use just a regular breakaway razor knife. You can use an X-Acto knife. I've seen people use scissors, things like that. But this is the tool that I'll be using. And essentially the process that I go through is to put a light cut on the edge of this heatsink and then go along the sides and down, then have one single removable piece. So let's go ahead and do that. Just a little bit of pressure, not too much, right down the length of the heatsink. Then we go down to the corner, do the same over here. And then we go down, follow the wire. Having done that, this should more or less come off with a little effort. I may not have cut quite deep enough. There we go. And it exposes the 3 wires that come in. As you can see, it has fairly large, pretty sloppy looking blobs of solder here. We may clean those up. We'll see how it looks once we get into it. I need to remove a little more material. You don't want any of this rubber insulation or plastic insulation to be up against these solder blobs, or else it'll make a lot of smoke, a lot of mess, a lot of stink. So we'll just clean that up a little bit with the razor. So the first thing that we'll do is we'll go ahead and remove the 3 wires that are on here. I'm going to use the soldering braid and get rid of most of, if not all of this material. If you've never used this before, it's basically just some thin metal braid. You place it on the solder blob that you're trying to remove, or the component you're trying to disconnect. You put the soldering iron on top of this, it heats up, it melts the solder, and it draws the solder up into it. It's a couple of dollars. You can get them at Radio Shack. I got mine at Radio Shack. And it should last you quite a long time. So we'll go ahead and it's nice and flat. I've got a little solder on here from the last thing I worked with. And so I'll just remove that piece, get a nice fresh spot to start. So my soldering iron should already be hot and ready to go. And this might be difficult to see actually from the camera, but essentially we lay the desoldering braid down, we press the tip on top of it, it melts solder, it draws it up, and it drew most of it up but did not quite disconnect the wire. I'm going to go ahead and just remove the wire by itself. And I apologize for my finger completely covering it there. And what do we have underneath? We have a very small pad here, which we'll be soldering our new wire to. So let me go ahead and do the same process to the other 2. I like to remove the used material from these every time I use it. That way you don't have to heat up that extra wire and that solder while you're trying to remove your next blob. We'll just do exactly the same. A little heat. And draws up the solder. And once again, it did not quite remove the wire. Just touch it with a little heat. here. Heat, solder comes in, and I almost had the wire out that time. And it came right out. And I always save these wires. Sometimes I find uses for them. I don't think I have any particular use for them on this build, but they're generally handy around. So the next thing I want to do is determine the positioning of this speed controller on our. So let me get out one of the frame panels. And these get sandwiched in between the two, so I will put this below this piece of frame, get the holes lined up, and this shows you how far back you're able to mount this. I'm going to go about as far as you can go, just a little bit of buffer room there, so that we don't have to worry about the wires being bent too far or anything. But right here is where this one's going to go. And to put it in place, I will get a good old zip tie. And I'm not going to worry about this being perfect. We will have a little bit of wiggle room there, but we do want the speed controller held down pretty firmly. So we have the speed controller mounted, and let me cut the excess of the tie off. I should have done it so that this part of the zip tie was on the side instead of on the bottom, because now I have to deal with it at an angle. That's not a really big deal. So with these motors, they come, I believe they sell them in clockwise and counterclockwise configurations. The default that comes with the kit is just the counterclockwise setup, and you can change the direction that the motor spins by changing the order that you've mounted your 3 wires here. Essentially, in my experience, every one that I've done, if you retain the order that they come out of the motor from left to right, when you are connecting them to the speed controller, they go counterclockwise. If you want to go clockwise, you just simply switch 2 of the wires in that order, and now you have a clockwise spinning motor. For the quadcopters, you need 2 that are spinning clockwise and 2 that are spinning counterclockwise. So we will do 2 each way. So here we have some regular old wire strippers, which come in very handy for things like this. We will look and see roughly how much wire we need on here in order to do this neatly. We want a little bit of extra, but not a ton of extra. So I'm giving myself about that much, and I will go ahead and cut the wire there, and then I will strip just the very tip of it, not much at all. And I've got about this much wire bared on the end. Got one. We'll go ahead and do them all the same length. We'll have a little bit of excess there, but that'll make the discussion a lot easier. We'll cut this in the same spot, and then we will bare a very small amount. And we'll do the same with our last one here. 3 wires ready to go, and not a ton of material coming off the end. Go ahead and twist the wire just so there isn't any frayed wires sticking off the sides that can short. And we'll do this one a straight through config, so it's going to be left, middle, right, just as it comes out of the motor. So let's see just to where it's on the camera. This is a little fidgety. The space is pretty tight for working with this. And I like to get completely lined up and have the wire oriented so that there's a little bit of downward pressure on it, just from holding it in place. And then we can give it a little heat. This one had some solder on there. It may not be enough to make the connection. Actually, it looks like it might be. Harden up, and you see we have one good connection there. Piece of wire coming off the other one. Alright, we'll do the same thing with the middle one. This one has an even smaller amount of material on it. I do have a third hand, or a helping hand, set up, but I'm not going to use it today. Alright, put it on top of the solder, put a little heat, let the solder melt into it. And then we draw the iron, give it a few seconds to harden. And that one did not have enough solder in it. I'll try it one more time. I think I'm going to need to add a little solder. And of course, I don't have my solder put out and ready. Here it is. And now we have 4 things to do with only 2 hands. So we go ahead and get the solder bent into an angle that should make it a little easier. Put a little heat on there, and you touch the solder to your wire, not to the soldering iron, and let the wire and your contact draw it up. And it looks like all the solder just went to the contact. This is obviously very hot, and you need to be very careful not to touch your finger or the power wire with the soldering iron. Get it hot, let the solder melt, hold it in place while the solder solidifies. And that's 2. And our third one will be a little tougher because we have this bundle of wire in the way a little bit. too bad. On mine I have a little bit of material on there that I think should be enough. Good heat to the wire. Oops. Be very careful to make sure that your wires, after you solder them, do not connect to the heat sink, which would cause a short. Let's check my work. I believe this is just a little bit of material that's not solder, but I'm going to make sure with my knife that there is nothing connected across there. And so this is not the most stellar soldering job here, but it'll get the job done for us. The next thing that I'm going to do, that I do on each of my builds, is I'm going to test this as a unit. And I have a article that I wrote with photos, etc., on how to build a ESC and motor tester out of an Arduino. Check that out on my website if you'd like to build your own. We'll demonstrate how it works. It's fairly simple. It's comprised of an Arduino, a push button, a little bit of code, and a couple of jumper wires on an experimenter's breadboard. But it does appear that I've borrowed my ESC pins for another project. But I have two of them, and so I'll just borrow these from that one. You have to be very careful on these when you're connecting them up that you have the ground on the correct side. On my build, the ground is the rightmost pin, which is the brown wire here. We'll get that connected up. Actually, before we do this, I'll test the BEC functionality before I even put the Arduino into play. So we'll bring this back in a second, and we'll get the multimeter. This is a Harbor Freight multimeter. You can frequently get them for free with a coupon, no purchase required. It's not the world's greatest multimeter, but it definitely can get the job done, and simple projects like this, it's more than adequate. So we'll need this. I have a adapter that I built to connect the XT60 connector to alligator clips, which is over here. Obviously, you'll want to connect the alligator clips to the ESC first before they're hot, and make sure they have ample separation to avoid a short. Connected to the battery, you hear it power up. These speed controllers, some of them do not make power-up sounds if they aren't connected to something on its control lines. So again, be very careful not to let those cross. DC setting on multimeter, and the brown is the negative, and the red is positive. The meter reads 5.01, 5.02 volts, which is well within the range of tolerance that we have for both the Arduino and for the so we'll go ahead and disconnect this apparatus, put our multimeter away, which we'll be using again in a few minutes with the next one. Bring out our Arduino setup, again making sure the ground is to the right on here. The alligator clips, one over, one under for that separation. And this will initialize the speed controller fully, power up the Arduino, which has a very simple Arduino sketch on it. When I press the button, it will send a 1500 microsecond PWM signal to the speed controller, which is equivalent to roughly half throttle if you were doing this through a radio controller. So pressing it should cause the motor to spin in a counterclockwise direction. Go ahead and hang on to the motor arm. Again, be careful with these. Make sure we have good connections there. And again, pressing the button should spin counterclockwise. So you see there is a little bit of torque on here. And it is spinning counterclockwise as expected. So we'll go ahead and remove the battery power and alligator clips. And we'll disconnect this from the test rig. Set this off to the side. And this one is essentially done up to this stage. I'm going to do one more, I guess, on camera to do a clockwise direction, and then I'll do the other two off camera. So we'll set this one aside, grab our next one. I do have a speed controller that I had already removed material on from earlier when I had the malfunction with the camera. Clean up our work area a little bit. And it'll be the same process. First I will remove the excess solder and the existing wires from the speed controller. So get a fresh tip on the desoldering braid. Soldering braid to the solder. A little heat pulls the solder right out. That one removed all of the solder, so I will definitely need to add new solder to it to connect our motor wires. There's two. That one left a very small amount. I may be able to get away with not adding. And our third one. Well, this one went a lot easier than the first one. And as you can see, very little solder left, if any, on these connection points. So our next step is to zip tie the speed controller to the arm. This time I'll make sure to have the clasp of the zip tie on the side instead of on the bottom, so that this will lie much more flat. And I'm not tightening these down too much. A little bit of movement possible there without the thing being able to come completely apart. We will check on the frame to make sure that we are in a good spot clearance wise. That looks good. A little bit tighter. And we will go ahead and trim up our wires. So again, you measure so you have just a little bit of extra when you do the bend over to where you're going to be mounting it. Take the tip off. And just a little bit of material comes off. And remove. I'll leave that so you can tighten it. Go ahead and cut the other two at the same spot. All of our wires will be exactly the same length. And we will strip, again, just a very small piece at the tip on the two remaining wires. Now, since this will be a clockwise spinning motor, we will start with the wire in the middle coming off of the motor. And we'll connect it to the leftmost solder pad. And bending the wire just a little bit so that when we hold it, there's just the smallest amount of downward pressure. This keeps the wire in place when you get the solder melted and pushes it against the solder pad. Get it right on the middle. There we go. A little bit of heat. Melt the solder into the wire, and I don't think there's enough there. Oh, there was a tiny bit, but I think I should add just a little more onto it. Move the wire again. Make sure it's nice and clean there. Smallest amount of pressure. And one nice little solder joint. There, I try to use minimal amounts of solder, keep the solder blobs as small as possible without being weak. So it's set up for the middle. This one looks like it has a little more solder material on it. Let's get the wire bent so it'll hold in place easier. And this is the wire on the far left side of the connector coming out of the motor, or out of the bundle coming out of the motor. Heat, get the solder drawn up, keep the pressure on, and the middle one is ready. One common mistake I see with soldering is people will try just dropping a blob of solder onto the junction that they're making. That's what's called a cold solder joint. In order to have a strong connection, the material that you're soldering needs to be hot enough to draw the solder up into it and get a good strong bond. So it's a little more effort, but it's a much stronger connection that you'll make. Tighten this wire up a little. This one, the desoldering braid removed basically all of the solder material, so I will definitely have to add. Pressure, just solder onto the wire, not onto the tip of the soldering iron. And remove the solder, let it harden. And let's see how we look. So same as on the last one. Before we go any farther with this, we're going to test it with our multimeter and then test it with our Arduino. I like to test at every stage of this, mostly because my confidence in the very cheap components is pretty low, and there's always room for error when you are removing wires and soldering on new ones. So I always test. We need a battery, we need our alligator clips. Connect first. Power, and we're on DC voltage setting again. And negative is brown wire, positive is the red wire. And this one says 5.03 volts, which again is well within the range of acceptable. Connect our power line, and get out the Arduino set, making sure the ground is in the correct position, and we have enough clearance alligator clips to keep things separate. And you see the Arduino powers up. I'll go ahead and hold this and press the button. And this this one is spinning clockwise as expected. So we'll remove power. And we'll go on to the next two, which I will do off camera. And I'll be back with you in a minute. Okay, I'm back. So I've gone ahead and soldered the rest of these, and I did notice that because of the placement of one of the holes in the arm, there's actually an alternate way that you can run your wires from the motor to the speed controller. Until I try putting landing gear on, I won't be able to say if this is a reasonable way of doing it, because it does seem like the arm gets it to its most narrow point right up against where the arm starts to expand again. So the wire might be in the way there. We'll see. If it is, then I'll go ahead and redo this one. If it's not, I'll be able to give you an opinion on if it's better or worse, or just doesn't matter. So let's see. We have two motors wired up for clockwise rotation, two wired up for counterclockwise rotation. The way to tell on them is just visually looking at the order that the wires have been soldered onto the speed controllers. Let's go ahead and get our frame out and figure out how we will be able to put these together. Let's look at the rest of the parts that are in here real quick, since we didn't do that earlier. These are the landing gear. There are 4. I'm not particularly fond of the way they're supposed to go on. Essentially sliding it on to here and then flexing the piece of landing gear over the edge here. I don't know how much faith I have in that working, but we'll try it. If it doesn't work and they break, those are just kind of the breaks. We also have this piece, which is a camera mount for your Sony CCD style camera. I'm going to put this in, but I'm not going to put a Sony camera on there, mostly because, frankly, the camera that I have does not fit very well onto these mounts, which I can show you really quickly. Get out of my little bin here. And on my camera, this little capacitor here is right in the way of getting this in place properly. There's definitely enough additional components and such on there holding this off to make it seem like it's not the greatest idea to use. This definitely cannot mount on the back, so the only way to do it reasonably would be with some additional standoffs, which I don't have. But I will be putting this in because I think it should add a little bit of strength to the frame while it's flying. The last piece, this is a camera mount that would be used for a Mobius camera, which is actually what I'm using to film this video. This will attach using these little rubber grommets onto the top plate here, giving it a mounting place with some vibration isolation that should improve the video that's coming off of it. And let's see. Because of the way this frame sandwiches together, You need to be aware of mounting things in the correct order. The parts that will screw your top plate to your middle plate need to be installed before you screw on the bottom plate and the arms, or else you just won't be able to get to them. Because of the lack of nylon mounting hardware, we're going to be putting the power distribution board on the bottom of the unit and the flight controller between the upper pieces. Normally you would mount the flight controller out here. Normally you would use those offsets to have the power distribution board mounted slightly above the base and the flight controller mounted slightly above the power distribution board. So if you do have these nylon fasteners, that's the way you would want to do it instead of the way that I'll be doing it on this build. Now this is my first build with the KK flight controller. So actually tuning it is probably going to be a separate video to get it to fly. I did look up in the documentation the order of your motors and the correct direction of rotation for them, which is different than on the Naze 32, which is what I usually use for my quadcopters. So it will be a little bit different. And so let's go ahead and get started with the frame. Put these landing gear away. We'll get to them later. Alright, this is the hardware for the top section and the Mobius mount. We will do the Mobius mount last because we can easily get to that. So we have 10 of these aluminum offsets. We have some screws. I'm going to use one of my handy Harbor Freight parts trays. They're magnetic so my parts won't fly away. And again, this is one of those nice things you can get for free with a coupon. So if you don't have one, it's really easy to get. These offsets are mounted with these shorter hex head bolts, 2 bolts per, so we'll need 20 of these little guys. Just setting them up in pairs. You can easily get 2, 2, 4, 6, 8, 10, 12, 14, 16. Oh, I'm sorry, there's only 16, there's not 20. So 2 of these goes back in. And we'll start with the top. You'll see your mounting slots are here, 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 and here. And you can compare that to the board underneath. The holes that you'll be using, you will be able to see straight through. Here, 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 and here. Now the tolerances on these holes, like the rest of the tolerances on this, are not very good. Normally you would be able to just push one of these screws through the hole. You pretty much need to thread it in on this model. And I think I'll flip this over so that the RCX letters are readable from above, but it really doesn't matter. Purely for aesthetics. Once you get it started, you can thread the spacer onto the screw, which will actually draw it through. Some of these, as you can see, is just going right through, whereas others I'm having to thread it through. Let's verify my screw hole location so that we're using the correct ones. Normally I prefer getting instructions included with equipment that I buy. This is my 5th or 6th frame that I've bought, none of which came with assembly instructions. 2 of them came with a what's included in this package, but that was it. It might be different if you spend the money on the $100 plus frames that are out there, but that makes it a lot harder to own 6. All right, and I misplaced my Allen keys here. These look like a 2mm hex head, which they are. So I'll switch over to that. And because of the tolerances on here, I'm going to go ahead and start all of the screws through. The guide that I'm using for which holes to use now are that they are essentially straight lines all the way across, so any of the ones that are offset obviously are going to be the wrong holes. Through. These inconsistencies in the size of the holes are usually caused by the equipment that's being used to cut these frames being worn. Essentially, the bits that they use are no longer accurately sized, so you end up with inconsistency. And that one slides right in, and that one slides right in. Again, this is completely symmetric, so it doesn't matter which end is the front. I will go ahead and put in this camera mount plate. Now's the time. It just kind of presses in there a little bit, not too much pressure. And then we match it up here. And get all the screws lined up. Tighten these in a little bit. I'm not tightening anything too much. I just need everything to be held together, but still able to wiggle around a little bit. Not ruling out that I'll have to take this back apart because I've missed a step somewhere, but I will be hopeful that I haven't missed any. They're all lined up properly. I'll go ahead and just cinch it down, but not tight. So all our dimensions should be correct. After a few of these, using these small tools, small fasteners, I might need to make a video on carpal tunnel exercises. So here is the top section of the quad mounted to the middle section. Sorry, that's actually upside down. This is the top of the quad mounted to the middle section. At this point, we still have the power distribution board to be assembled. We have the arms for the quadcopter to be assembled. And we need to see what the best way of routing these wires is going to be, since the power distribution board will be underneath instead of on top. So without paying attention to which arms I have, I'm just going to kind of size up where we are with relation to the length of our wires, their ability to reach the power distribution board, and it does not appear that that will be an issue. It would be a lot cleaner if we were using those standoffs and we're mounting this in the top section, because all these wires want to go up and not down. But not much we can do about that. Some people will have bought a stretch of power cord with their battery connector on it already. I choose to build my own. I use the H250 adapters, and I seem to put them on everything, so I buy them rather frequently, even though I never actually destroy them. So what I'm going to do now is very quickly make an adapter for it. I have some 18 gauge wire that I'm going to use, and let me just eyeball how far I think it's going to need to go. Typically the battery will go on top of the model. There does not appear to be a wonderful way of getting there other than coming out the side. It would be nice if there was a slot maybe all the way in the back. I could just go all the way around the back. In fact, that's probably what I'll do. So we need about 3 inches, about 2 more inches, and about 2 more inches. So we'll just say, we'll say about 8 inches of wire. Which will be roughly like so. Pull this up and through, and then we'll have our H250 connector there, and our wires mounted to our power distribution board there. Although using that, we won't be able to remove the power distribution board, so I will skip that hole and we'll just go all the way around the back. Definitely not optimal. I'll put a zip tie on there to try and make it a little more reasonable. But this is one of those things that you just have to deal with when you're using an inexpensive frame like this. Some of those things just won't be well thought up. So we need a little bit of material here on both ends of this wire. The included power distribution board is a little different from what I normally use, which is the Afro power distribution board. The way it's set up, your input power are these two here, kind of towards the middle. We do have on the KK controller board, we do have a battery voltage sensor, which I'm going to try to also connect, and unfortunately it's just going to have to connect that up to one of the ESC mounts, which isn't a big deal, but not quite what I would like to do. I am going to use my helping hand on this for my H250 connector. So first we will bare a bit of this wire. On the H250, the negative is on the pointy side. And once again, this is a cheap Harbor Freight thing. For a couple of dollars, it can make a lot of this soldering much easier. Nice and set up there so that there's a slight amount of pressure pushing down from this wire. Because this is a new connection, obviously we're going to need the solder. And I'm going to clean the tip with a little bit of brass scrubby. A clean tip will transfer your heat a a lot more efficiently than a dirty tip. So I'm putting the soldering iron in, making sure that I'm touching both the wire and when I'm mounting the wire too. And it heated up quickly. We just put some solder in there. Let it soak into the wire, and then we let it cool. And you can see the wonderful connection that this made right there. We'll flip around, adjust the wire. Still kind of warm. Same way, just a little bit of downward pressure naturally from the angle of the wire. Make sure to touch both the wire and what it's being soldered to. There we go. And it sucked the solder in. Give it a moment to cool. And now we have a nice XT60 header on here. Bear a little bit of wire on the other end. This is going to be a little more difficult because of the way that we're going to be mounting this to the bottom and the fact that carbon fiber conducts electricity. We're going to have very little coming off the backside of it. We definitely do not want there to be the possibility of a short happening on here. So what I'm going to do is actually solder it from the back, get both wires through, and I'm going to not use my helping hand on this. So a little more work into positioning it. So we'll put the tip so that it's touching both the wire and the metal on the power distribution board. And get it nice and hot. Hold the board down when you remove the iron so that it doesn't float away. And you can see the connection made there. We'll do the same thing with the other side. Again, you don't want to touch the solder to the iron. You want to touch it to the material that you're working with so that it gets absorbed. And it forms a strong bond. here we have very minimal amount of material coming through on the back. So this will make it much better for using our Velcro to hold it all together. So looking at our frame and we will be mounting this, we can see which side we need for which arms. I did go through, as I mentioned, and verify the order of the motors to work with the KK 2.1 board. This is a Quad X layout without any offset on the board, and the order is different than it is on the Maze 32 controller, so we need to be aware of that. So for the top left is what it's going to call number 1. That's a clockwise rotation, which means that it has the wires switched. And I believe this one was switched. We'll verify by inspecting it. Yes. So this is a clockwise spinning motor. Number 2 is the top right, and it is a counterclockwise spinning. Number 3 is the bottom right, and it is clockwise. This one, and number 4 is bottom left. It is counterclockwise. And so what we can do is go ahead and solder the power connectors onto here. We'll see what is the easiest to connect to. We'll move our signal wire out of the way. So we have connectors on the sides, as well as connectors on the top and bottom. And of course I have this upside down because sorry, I have it the correct way. I do not have it upside down. So negative and positive junctions. And we'll do just like we did with the power connector. Short wires, and they do have a little bit of solder on them already. And I'm purposely not using the helping hand. So we'll start with the negative. Heats up. We'll apply a little bit of solder. You don't need to use very much at all. On to the positive. Demonstrate these solder connections. Once again, very little material poking through. Now on the next one, the power wires are reversed. And so I think we will go around the corner and we'll use the mounting hole bottom instead of the ones on the side, which keeps us from having to cross them and should save us a little bit of reach on those wires. Start with the negative. Wire fell through. We will start instead with the positive because it holds itself a little easier. That in place, that should help keep the negative where we need it. First two, go ahead and rotate the entire apparatus. This one will be mounted at the bottom. Solder is all it takes. And our last motor will mount to the side. That's it for that. Now, because I want to use the battery sensor, I need to get one more connector from my spare parts. If you don't have one, then you can just skip this step. This is not the perfect connection, but it is close enough. This is a servo lead that you can get from your hobby shop for not much money. And it has 3 leads, whereas we only need 2 for a battery sensor. And it is clearly much too long. I believe there's no issue with using a 3-prong connector. And we have positive, negative, like so. And let's see if we have any interesting routing options for this. I would say we do not. So we'll simply cut it here. And I'm going to remove the yellow wire all the way down because we are not using it. Split the wires. These are pretty darn thin. Should be no problem for these strippers. And our battery connection is on the left side of the flight controller. This is currently upside down. So I will rotate it to its normal configuration. And we will wire this to right here. This wire is much thinner. I'm going to try not to melt too much of the insulator. I'll even do these one at a time. Heat it up. Dab. Let it solidify. It's interesting that they included a buzzer. I suppose the buzzer will also alert you to it being armed and things like that, but using it as a low battery alert is, in my mind, the more important duty. And that is the power side of our build. I may no longer need my soldering iron. Let's go ahead and pull that and let it cool off. Because I'm a bit of a stickler, I'm going to remove a little bit of the material that is coming through here with these dikes. really want this to be as flat as possible and without anything pointy coming through it. If I didn't mention before, the Velcro is not better than the standoffs. I just think most people are going to have, are not going to have those standoffs based on them being featured in the photographs on the product page, but not present in the bag once they receive their package. Actually, mounting this will come a little later. I want to have everything that can easily be removed done first. So again, the tail for the power is the rear. This will be mounting right in the middle. And our arms will be mounted like so. And sandwiched through to there. So without further ado, we'll put the rest of the frame together. We have these longer 8 or 10 millimeter M3 bolts which go through to hold the propellers, and very, very small hex nuts here. Let me see if I have the correct socket. These are metric. I have an SAE set. 7/32 will do the job. Although it may not be possible to do this with the top plate mounted on. Being the first time I've built this frame, I would not be surprised if I had to remove some things during the assembly process. Go ahead and flip the entire thing over. Drop one screw. These plates will sit on top of each other, and the arms will slide in between them, leaving the power distribution board, as you see on the bottom. I'll line up the first one. Second one through, or part of the way through, and that will give us some stability for doing the rest of them. have to thread through again because of the poor manufacturing tolerances. But for the price, you can't really complain about things like that. Okay, each of our arms has 2 screws through it, holding things roughly in place. You can see we definitely do have plenty of reach on our power lines, so when we actually fix it up, there will be enough slack for making it still easy enough to disassemble should we need to replace any part, which is likely. So I'll contemplate for a moment if there's anything stopping me from putting the rest of the screws in. And there may be one thing. Actually, no, I think we will be okay. In the assembly of the top and middle pieces, we did not tighten those screws appropriately. They're just resting there. So I'm going to see if we have access to all of them through the bottom plate. It appears that we do. So without further ado, I'll tighten those up. And you can just go right through the matching hole in the bottom. Again, we're not putting a lot of pressure on here. It needs to be tight enough to resist falling out because of vibration, but these materials won't tolerate being tightened too much. Very easy to over torque it. And this one was actually fairly loose. Now it's fairly tight. Since we've done that, we'll follow up with tightening from the top as well, which mostly should be done from tightening the bottom. It'll cinch it together. And it may be completely done, in fact. If you've ever worked as an auto mechanic, then you'll understand what I mean when I say you want about 1 finger worth of tightness on these things. Any more than that is going to cause breakage. So let's go ahead and put the rest of our long fasteners in place through the arms. fully aligned roughly where it's going to be permanently. Now putting these fasteners in could be a little tricky. Just fitting a tool in there to hold them. These nuts are very small. And they do have a nylon washer in there which keeps them from vibrating loose. So we will get started on one. Down to that nylon. And we'll see if the ratchet will fit. That looks like a no. We'll see if I can tighten it using just my fingers on the socket. That looks like a yes. A wrench would be a better plan. But this is what I have handy, and it works. There are 16 of these in total. So I apologize, this will take a minute. Because everything is otherwise assembled, I'm putting the full amount of torque that I'm going to put on these now, so I don't have to come back and tighten them back up. The burning question is, will I edit this part out of the video? Probably not. It would definitely be better to use a wrench. And I believe I have wrench that came with the toolkit for my radio controlled truck that would do the job. And I'm on a roll. And I'm getting adequate tightness this way. A little more challenging for some reason. There we go. Two down. Start all four of these. These things are much easier to do when you're not holding things for a camera, which I'm sure I'm not doing the greatest job at. this point, the arms are all mounted and ready to go. I'm going to go ahead and tighten up the zip ties and remove the excess material. We're getting pretty close to a finished product here. One of the very last things that you do, that I may not even cover in this video yet, is attaching the propellers. However, you do need to attach on these motors, you need to attach the propeller mounts. And so I'll do that real quick. You need a very small Phillips head screwdriver, which I have, of course, in the form of a Harbor Freight kit. And we'll be using these very small beveled head adapters, or screws. I need a smaller bit than that. Which I believe is maybe this one. And it's stuck. This one is labeled PH0 and it is the correct size. So the prop adapters have 4 holes and a propeller mount coming off the top, and there are 4 holes on top of each of these motors. Cinching them down but not tightening them at first. Come back and tighten them once they're all threaded in. This is my first time using these types of motors where you have to attach the prop adapter manually. As of yet, I don't have an opinion on if that's good or bad. I'll grab our next one. Again, very lightweight, very cheap materials. You cannot put a whole lot of torque on these. I'm not going to put the screw caps onto these yet because I may do motor testing before I'm done, and they tend to fly off if they're not tightened down. That step is complete. Let's eyeball our flight controller. One thing I don't like about this is that all of the labeling is on the back. So before I do too much more, I'm going to take a photo of it that I can refer to when I can't see the bottom anymore. Close, get focus, and we'll go. Now on all of these connectors, they are ground on the outside, except for battery and buzzer. The buzzer doesn't really matter. The battery absolutely matters. So that's a good reason to have taken a photo. Let's look at the orientation of this. I believe our next step is going to be Velcro. I bought the large pack of the industrial strength Velcro, which comes in a big pack, several feet of it. We're only going to use a little bit for this. And I'm going to grab scissors to make this easier to cut. Okay, I've got these scissors. Now these are sticky on both sides, so you can stick it to whatever. And I like to put the softer side on what I'm connecting and the harder side onto what I'm connecting to. Not for any particular reason, I suppose. Looking at the layout of this, I think we'll just do 2 strips to connect the power distribution board. We'll go about a 1/2 inch wide. These are some utility scissors from Harbor Freight. You can get them for free with a coupon, or they're usually about $1. So it'll be a little tricky getting it in there with all the wiring already in place. I'll go ahead and peel the backing off of the stiff side that's going to the frame. And I'm just going to slide it in and press it down. And we'll do the same with this piece. Press it down. These are actually the perfect width for this frame. There's nothing coming off the sides. I'll take the backing off of the soft side that will be attaching to the top, or to the power distribution board rather. Both pieces so that we're doing this all in one shot. It's hard to do without thumbnails. Alright, and make sure to line it up pretty straight. Doesn't matter that much on the power distribution board. And we'll press it down. Now, being Velcro, we should be able to remove this at a later time if we needed to. But it is definitely inferior to mounting with nylon fasteners. So let's look at our controller board. The buttons are on the bottom, which will go towards the back. And our receiver connectors mount on the left side, and our ESCs mount on the right side. We can see roughly the space that we have to work in between these screws and these screws, and we will cut essentially the same size strips of Velcro. One nice thing about the Velcro is it will offer a little bit of vibration damping, so that could be helpful to the flight controller. The big downside to not using screws is that you are never going to get it as straight as if you were using screws. We will remove backing tape, eyeball this again. So we're going to go, because you won't be able to see it on the inside, I'm going to go right up by the edge so that we are just covering these holes. Press it down. Tape. Line it up and press it down. And we'll take the backing off of the top piece of the Velcro. Again, is easier if you have fingernails. We're going to do our best to put this on as straight as possible, because that can affect how this thing flies. We get it pretty well lined up, and it looks like the best place press for the bottom is going to be on these pin headers, maybe. It's hard to put a lot of pressure on here because you don't want to flex it too much, and you definitely don't want to push on the LCD because it's not there to be strong. All right, let's refer back to the photo that I took back of the board. And I'll go ahead and put the accessory items on. Our buzzer goes to the topmost connection. It should not matter which end you use for ground, and connect the ground to the proper one, which is towards the center of the board. And let's tuck this away. And the battery sensor, also the ground is towards the center of the board, and that is the second connector down here. So we'll go ahead and plug that in, and we'll deal with the extra wire from this a little later. And just to test and validate the connections to the power distribution board before we plug anything more into the controller board. And actually, I will unplug the battery sensor from that first as well and test it along the way. So right now, the ESCs are all wired to the power distribution board. The battery sensor wire is wired up to the power distribution board. The flight controller is not connected to anything having to do with power. So we should now have 12 volts roughly readable from this connector, or whatever voltage is left in my battery pack. And 12.4 is what we're getting. So nothing interesting happened. That test was easily passed. Remove the power. Battery sensor again, ground towards the inside. Tuck this away through here for the time being. Our motor order 1, 2, 3, 4, which is different than on other flight controllers, potentially. So I'll run our ESC connector back. This will actually be tight reach, or tight enough reach, but dual. And this is motor 1. Ground goes towards the inside. Or, I'm sorry, ground goes towards the outside. And so number 1 is connected. Number 2 is the other front on the right side. So we'll do the same thing. Around that connection, ground toward the outside. The ground again is the brown wire. This one should be the toughest reach. I'm sorry, that's number 4. Number 3 is the back right. I'm going around the frame posts here, which should help control the extra wire. Get that wired in. And finally, number 4 is the back left. And this is definitely the toughest reach of the bunch, but still it reaches. There's almost tension on there. Almost. Now, if you had been tempted to go ahead and put your propellers on, that would be a mistake at this point. You never want to have your propellers on for any testing whatsoever. It's a great way to injure yourself or damage your model. Just rerouting this buzzer a little bit. I suppose before I go and start with the flight controller, I'm going to attach the Mobius mount, which is these wonderful little rubber grommets. And they're a bit of a pain in the butt to squeeze through. Even more of a pain in the butt to do it while trying to be visible on a camera. Just try to pinch it a little tight, push it through these holes. It helps once you get a little bit through to try to pull it through on the other side. I mentioned I'm currently using my Mobius camera to film this video, and so I will not be able to show a video of actually having the Mobius on here. I do not know how effective these are going to be, but certainly it'll be better than nothing. Spun that one right out. I'll be really good at this about the time I'm done. Presumably this goes this way. This will be much harder because we can't move it around as much. I would say this could be considerably more difficult. On the upside, you can see what you're doing a lot better. And I pulled this one out of the bottom. these too hard because they're wimpy rubber. Will surely just pull apart. This one that pulled out from the bottom. That's going to be the tricky part, is getting all of these in at the same time. It's a bit like whack-a-mole. Now they're all mounted. It's roughly straight. Maybe not perfectly flat, but that's as good as we'll get for the moment. So where are we? We have the receiver to attach still, and I have a D4R2 that I use on basically everything. It's definitely seen better days, but still works perfectly. And this receiver and controller both do CPPM mode, which allow you to run 8 channels off of a single connection. So obviously I'll be doing that. One trick is keeping your receiver wires away from your propellers. Generally speaking, you can go down with them, and that should keep them at bay. So I'll go down through these holes that were provided for symmetry in case you were running your Sony camera on the mount and had your frame turned around this direction. This receiver wire has gotten significantly shorter than when it was new, precisely from propellers. So we get both of those in. Pull our connection through between the frame pillars. And I'm going to go ahead and put a small zip tie on here. Actually, let me flip this around the other way. so that we leave a flatter surface for the battery to mount. Receiver nice and tight. Take the rest of the zip tie off. And the instructions for the KK1 say that to run CPPM mode, you connect your receiver ground towards the outside to the first channel, which is at the very top. I'm trying to do this in such a way that we'll still be able to see the display on the flight controller. And there we go. See, we've got a little movement here, which we don't want. Slide it back to where the arm is a little wider. Tighten it up some for us. And now we are electrically complete. We will need some Velcro here for holding our battery. I use this Velcro, comes in a roll like tape. And we'll use these slots on the side. We need a little more than what it takes to go around there. Through and go through the outside to the inside. We have to double back on it to connect to itself. This is a pretty small little battery, probably only good for a couple of minutes of flight, but plenty to do testing with. And this piece of Velcro is not going to be adequate the way that I've done it. So I'm going to discard the attempt to double back on itself. We're just going to run it through these holes, through the bottom, and back up. Like so. So this being my first attempt to use the KK controller and not being able to see it very well, this might be difficult to see on camera. I will go ahead and remove the battery and the battery cable for now so that I can see through the holes here and be able to read the screen a little better. So this is the first time this thing will have gotten power to the flight controller, and hopefully it does not just explode. This is not going to be very photogenic. Safe. It says self level is off. Error, no yaw input. Battery 12.1 volt. Temperature 29. Roll angle, pitch angle, and menu. Let's try menu. Okay. PI editor, receiver test, receiver sliders, mode setting, and stick scaling, and we can go down. So first we need to do mode setting. Setting, we'll back out of here. Definitely not easy getting your fingers through here. Miscellaneous settings, self level, camera, NPU, sensor test, accelerometer, calibration, mix editor, show motor layout, load motor layout. Okay, and here are the different models we have available: single copters, dual copters, tricopters. Y6. Go through our list here. Bunch of different models. And there it is, quadcopter X mode. We would like to choose that. Are you sure? Yes. And it's showing the diagram of our motor layout, which I'll just verify real quick. Matches. It does indeed. And next. Motor 1. Direction seen from above, clockwise. That matches what I had. Motor 2, direction seen from above, counterclockwise. Motor 3, seen from above, clockwise. Motor 4, seen from above, counterclockwise. So those all match. There's no motor 5 or 6 or 7 or 8. Is there okay here? It's taking me through the same thing. Alright, hit back. Oops. Alright, maybe we're just supposed to back out. Got channels, roll, pitch, throttle, yaw, and auxiliary channels. And this is probably going to take some tuning with my radio. I did see they have some sliders we can look at. And so let's go ahead and grab the transmitter.
Welcome to Free Sky Tyrannus. Switch warning.
Alright, we are connected now. I believe we still need to enable a CPPM mode somewhere. Nearly impossible to see this. I'm going to go ahead and stop recording and read the manual. Okay, I have gone ahead and done a little bit of tuning on this thing, and as you can see, finished assembling it, put the propellers on. I was able to get all of the landing gear on without them breaking, although I was kind of surprised that none of them broke when I was doing it, because it did take a significant amount of force to get them on there. So I'm not excited about how they got there, but they're there and they're working. I did go through the KK flight controller and enabled CPPM mode, set the channels to match the outputs on my radio. One thing that was a little surprising to me was that 2 of the channels had to be inverted. The rudder and the elevator were both essentially backwards according to the KK flight controller. That's not something that I've had to change in the past with my Naze 32s, but once I figured that out, it wasn't a huge deal. I did go through and look at the PID settings, and the figures that you see in the controller for those are well outside the range of what you see when you look online. With the P gains at 250 compared to advice on the internet saying to put it somewhere near 50. I did try dropping those down to the settings that I saw online, and that made it much worse as far as flying goes. So I've dropped them, or I've raised them back up to P setting of 250 or P gain of 250, and that seems to have made it fairly reasonable. There's still a little tuning to be done, but it's at the point where it can fly a little bit. I don't know if you can see, I do have a little bit of damage on my new propellers from bumbling around while I was doing that tuning, but so far nothing's broken and no major incidents. So let's see, what else do we have on here? I've got a larger battery because my small battery was dying. I put a zip tie to hold the buzzer and removed the cover from it, which actually muffled it considerably and made it almost inaudible when my first battery was on its way out. So that one actually got quite a bit lower than I would have liked. But either way, this is all together. The propellers are on in the right direction. They are tightened down pretty good. They're hard to tighten because the holes in the screw caps will only take about a 1.5 millimeter Allen key, which doesn't really have the diameter to be particularly strong. So you have to be careful when you're tightening them. You do want them to be pretty tight, but you don't want to destroy your Allen keys trying to do it. So next thing that I'm going to do is see about videoing a test flight of this in my office here. It's a little bit too windy to take it outside, but I'll try and set the camera up to take that, and then we'll try actually putting the Mobius on the Mobius mount and see how that looks.